Today's video is for Pre-Algebra, Chapter 2, Lesson 3 and 4. The quote comes from Horseradish, Bitter Truths You Can't Avoid by Lemony Snicket on page 68. Everyone should be able to do one card trick, tell 2 jokes, and recite 3 poems in case they are ever trapped in an elevator. All right, math time. So simplifying algebraic expressions, variables, and equations. So this is 2 lessons slammed into one video. It's not too big of a deal though, it's relatively short. Okay, so a term is a number or the product of a number and a variable. How I like to think about it is anything that is separated by addition or subtraction. So if I have A plus 2B, A is a term and B is a term. Okay, and then even if I have plus 12, 12 is also a term. Then I could even subtract C if I wanted, and then C would also be a term because they're separated by addition or subtraction. And again, they can be a number or a letter times a number. All right, a constant is a term that has no variable. So if I were to look at the previous example, the 12 would be a constant. All right, it's just a number. All right, something that has no variable. A coefficient is the number in front of a variable. So in this case, it would be the 2 or the invisible 1 in front of the A or the invisible 1 in front of the C. So coefficients are when you're multiplying something times a variable. Like terms have the exact same variable and the same exponent. You don't have to worry about the exponents today because there's none on your class assignment, but later on you're going to have to. So let's go ahead and take a look at another example. So we have 6 plus 2s plus 4s. So the 6 is a constant. The 2 and the 4 are both coefficients. And the 2s, sorry, Miss Michelle walked in. All right, so the 2s and the 2,4 are both like terms because they have the same variable, okay? All right, so next example is negative 4x. Well, negative 4 has a coefficient of negative 4, and it is a single term. All right, from number 1, the example has actually 3 terms, though if you were to simplify it, it would simplify down to 2 terms, 6 plus 6s. All right, next example, we have 9m plus 2r minus 2m plus r, and the coefficients are 9, 2, negative 2, and 1. All right, and the like terms, and so this one has 4 terms, but the like terms are 9m and negative 2m, and then we also have another set of like terms, which are 2r plus 1r, okay? Yep, and there's no constants in number 3 or number 2, but number 1 has the constant of 6. Okay, and again, you can see they're all separated by addition or subtraction. There we go. Okay. That's a little messy, but you guys got it. All right, next up. Always add the opposite before anything else. All right, if there's a subtraction operation in there, or minus, you need to add the opposite, and the opposite always goes to the second integer or the second number. All right, so simplifying an algebraic expression means to combine and perform operations until an equivalent expression is formed that has the least amount of terms possible. All right, and we can do that by combining like terms, and we only add or subtract like terms, but the terms also have to have the same variable, and then the variable itself also has to have the same exponent. So here we go. This first equation starts out with 4 terms, and we need to simplify it down as far as we can. So when we're combining like terms, we're going to add things up that have the same variable. And the other thing I forgot to say about combining like terms is you're going to combine constants. And the constants here are going to be underlined in orange. So the constants can be added together, and the constants that have the same variable get added together. And we can do this and rearrange things using the commutative property of addition. Since everything's being added, I can move things around. So we're going to end up with 3a plus 4a plus 2 plus 1. And again, I'm going to combine the like terms. So those have the same variable, and the constants here are the same. So when I add them up, 3 plus 4 is 7a plus 3, okay? And so that is actually as simplified as it gets because the constant cannot be added with the 7a. They are not the same, they are not similar terms. They are not like terms, so I can't add any further. So don't get add happy, okay? So next up is this example. So the quick and dirty way to do this is just to add the coefficients, in this case the 5 and the 1, but I'm going to show you how to do this using the distributive property, okay? So what can I extract? You guys remember that extraction term from the last movie? Well, I can extract the y. So I'm going to pull the y out, which is going to leave me with 5 plus 1 y. Well, 5 plus 1 is 6y, because 6 times y is 6y. And I actually could have done that here too, where I could have extracted the a and gotten 3 plus 4a. Well, 3 plus 4 is 7a. And then obviously I still have to add the constants there. Okay, so this is the extraction method of the distributive property. And again, you don't have to do it this way as long as you know that you're just adding the coefficients and then sticking the y back on. But this is the distributive property in action, but it's usually a step we can skip because most people just do it in their heads mentally. Okay, so again, that's adding the coefficients. All right, because again, the coefficient is the number in front of the variable. Okay, so let's go ahead and simplify some problems, or excuse me, some expressions, because expressions do not have equal signs. So just a quick reminder, when you have a letter all by itself, there's actually an invisible 1 in front of it. And there it is, that's just an invisible 1. Because once you have that invisible 1, it's really easy to visualize the fact that you have 3b minus 1b. Though, don't forget, you got to add the opposite, because adding the opposite will really help. It might not help for this particular problem, but it is going to help you later on in the future. So I'm going to go ahead and do the distributive property extraction method real quick. And I'm going to pull out the b, and 3 plus negative 1 is 2b. When you could have also done 3 minus 1b, which is going to give you 2b. Okay, next problem. Add the opposite. It's going to really help you here to add the opposite, because then you're going to end up with negative 4m plus negative 9m. And I can do the extraction method here, or I can just add, because it's a negative plus a negative means my answer is going to be more negative. So we've got negative 4 plus negative 9m is going to give me negative 13m, which again, you could have just added the coefficients and then added on the variable. All right, next problem is 6y plus 4m minus 7y plus m. I'm going to go ahead and do is add the opposite, and I'm going to get 6y plus 4m plus negative 7y plus m. And then I'm going to use the commutative property of addition, since everything's being added, and move things together that have the same variable. So there we go. So then these are going to get combined, and then I'm just going to add, you can use the extraction method of the distributive property, or you can just add the coefficients. And 6y plus negative 7y is going to give me negative 1y plus 4m plus m, remember there's an invisible 1 in there, he's just invisible, is going to give me 5m. And that's as simplified as I get, because y and m are not the same variable, which means I cannot add or subtract them, because they are not like terms. All right, next up, equations have equal signs, of equal signs. There we go. Well, yeah. Equations have equal signs. Okay, so numerical expressions have only numbers and operations and are either true or false. And algebraic expressions are also known as variable equations. Your textbook flips between the two, have numbers and variables and operations, and are called open sentences. So 4 times 5 equals 20 is an example of a numerical equation because it has only numbers. And it is a true statement because 5 times 4 is 20. So that one's true. Next one is 9 minus 7 equals 3. Well, 9 minus 7 equals 3 is a numerical expression. The only problem is it's false. 9 minus 7 is 2, which does not equal 3, so that's why it's false. And then we have 8 plus x equals 2. Since it has a variable in it, it is an algebraic or variable expression, and it's called an open sentence automatically. So let's go ahead and convert 20 minus 3 times x is 2 to a numerical equation. While 20 minus 3x, or 3 times x, is 2. Just remember the is means equal sign, okay? But since there's a variable, that means it is an algebraic expression, and therefore it is an open sentence. All right, any variable means an algebraic expression, and it is an open sentence. All right, I've got 2 more problems left. So is the given number a solution for the equation? Basically, they want to know is if I plug 1 in for t, do I get a true statement? Well, let's go ahead and check this out. I've got 8 plus 1, because t is 1, equals 2 times 1, because again, t is 1. Well, does 9 equal 2? No. That means it's false. Okay, so that means that the given solution is, or the given answer, 1 in this case, is not a solution for the equation. All right, here's the last one. They want to know if I replace m with 6, do I get a true statement? Well, 9 minus 6 equals 3. Well, 9 minus 6 is 3. 3 equals 3, which means it's true, which means 6 is a solution. All right, guys, that concludes the video. Have a good day. Bye.